Let's start with an assumption that happens to be a fact. The noise coming from an accessory drive is not usually the fault of the belt. Noise generated by a belt can be of several types and can be caused by a variety of problems. Sometimes installing a new belt may seem like a fix, but if the drive is not inspected and problems like misalignment and tensioning are not remedied, the noise will return along with a dissatisfied customer. This video focuses on the two main types of belt noise, chirp and squeal. These are different noises, and they have different causes. Chirp is a series of sharp, intermittent noises. As belt speed increases, the pitch and volume of chirp remain constant. Chirp is most often a result of misalignment between consecutive pulleys on a drive. It can also be caused by an improper installation, extremely worn belt ribs, worn pulley bearings causing wobble or free rock, or fluid contamination. Chirp occurs more frequently in poly rib drives than in V-belt drives. The most common cause of chirp, misalignment, can be either axial or angular. Axial misalignment is the most common, but both should be checked. Squeal is a relatively high-pitched noise, typically lasting several seconds, which does not change in pitch but may change in volume as the speed of the drive changes. Squeal is the most common type of belt noise. It may be continuous or it may be intermittent, changing with acceleration or added accessory load. For example, the air conditioning compressor engaging. As mentioned earlier, a new belt can seem to resolve the noise problem. Most brands of belts now contain fiber, especially Dayco's W-profile belts. Once the fiber has worn off the surface of the belt and the ribs become seated in the pulley, the belt performs more aggressively. And if the misalignment has not been identified and remedied, the noise problem has not really been fixed. The direct cause of squeal is relative slip between the belt and pulleys. Usually the slip results from low belt tension due either to low installation tension or tension decay from belt relaxation or actual stretch or sidewall wear. Slip may also occur due to high loads resulting from bearing drag or an accessory on the verge of failure. An under-designed drive slips due to high accessory load or insufficient wrap on the driven pulley. Belt dressing or contamination by oil and antifreeze or other lubricants may also cause slip. Regardless of the belt noise, a solution that will not work and is not effective and will destroy the belt further is the use of belt dressing, which should never have been invented. Window washer fluid or any petroleum-based engine fluid, such as oil, antifreeze, power steering fluid, brake fluid, brake cleaning fluid, transmission fluid, gasoline, or diesel fuel. Here's a noisy Dodge Ram. In order to determine if this noise is a chirp or a squeal, one method is to spray the rib side of the belt with water. If the noise diminishes or is temporarily eliminated but returns when the ribs dry out, the noise is characterized as chirp, caused by pulley misalignment. The first order of business is to disconnect the battery for safety's sake. The two possible methods for checking alignment are using either a straight edge or a laser tool. For either method, the crankshaft pulley should be used as the base or reference point. When using a straight edge, various pulley flange designs can make flange alignment impossible, inaccurate, or both. A better approach is to measure from the straight edge to a designated pulley rib, in this example, the tip of the second rib in. To use this method, first align the straight edge against 2 points around the crankshaft pulley. Then, using a measuring tool, such as a caliper, measure the distance from the straight edge to the top of the second pulley rib. Lock the caliper on this distance. Next, maintaining the 2 points of contact on the crankshaft pulley, proceed to another pulley, in this case the power steering pulley, and check the distance between the straight edge and the second rib on the pulley. Any variation from the locked distance to the top of the second rib indicates misalignment. In this case, the alignment is off by approximately half a rib. To use the laser tool, install it on the pulley being checked according to the manufacturer's instructions. The power steering pulley is frequently the cause of misalignment because it's simply pressed on the shaft at the factory and not installed to a stop point, so the pulley is often pressed on too little or too much. This pulley has been pressed on too far, so it's been overpressed. This pulley hasn't been pressed on far enough, so it is underpressed. The correct installation of most power steering pulleys is to have the pulley even with the end of the shaft. If the power steering pulley has been overpressed, a power steering pulley pulling tool is needed, available from most automotive tool catalogs and parts stores. To use this tool, a collar is locked around the small flange on the edge of the pulley. Then the pulley is backed off the shaft until the pulley is flush with the shaft. To correct an underpressed condition, use a power steering pulley installation tool, also readily available. Screw it into the interior thread on the shaft, then tighten the washer against the pulley until it is flush. Note that the two tools perform different tasks and are not interchangeable. Another seldom diagnosed cause of misalignment is the water pump pulley. If the water pump isn't leaking, it's okay, right? Wrong. This belt is creeping out of alignment upon acceleration. The water pump has a bad bearing and should be replaced. Here is that same water pump on the bench in a vise. Notice how much free rock is present in the pulley. In this situation, the belt is constantly pulling the pulley out of alignment, a condition that is magnified during acceleration. All remaining pulleys in the drive should also be checked. Look for damaged pulleys. Spin them, listening for a grinding sound that indicates a contaminated bearing, or freewheel, which tells you there is no grease left. Also, check for free rock. A little is acceptable, but too much means the pulley should be replaced. While the belt is off, examine the tensioner movement through its total range. Does it bind at certain intervals? Does it feel sticky? Is it locked up completely? Any of these conditions is cause for replacement. If a belt had been making noise, chances are the edges have been damaged or the ribs have been glazed, so a new belt should be installed. Often, a belt routing diagram is provided on the vehicle and on the back of Dayco serpentine belt sleeves. Be careful, it's not that hard to install the belt one rib off, especially on the lowest pulley, which is typically the most difficult to reach and see. If this condition is not remedied, the overhanging rib could be cut completely off, or the entire belt could flip off. After installation, have someone crank the engine once or twice, and visually check to verify that the belt is seated correctly in all pulleys and tracking properly. If everything looks good, start the engine. A properly aligned and functioning accessory drive with a new Dayco belt will provide years of quiet, trouble-free service. Here's a noisy Chrysler 300 with a lock center tensioned accessory drive. In order to determine if the noise is a chirp or a squeal, one method is to spray the rib side of the belt with water. If the noise gets louder, it's technically a squeal, and therefore a tension issue rather than misalignment. First, disconnect the battery for safety's sake. Since this is a locked center tension drive, the adjustable idler pulley should be inspected first. Spin it to check for lockup, binding, or gravelly sound. If it freewheels, the grease is gone. Also, check for free rock. A little is okay, but too much means the pulley should be replaced. Next, inspect any remaining pulleys in the drive and replace if defective. If all the pulleys check out, or defective ones have been replaced, the next step is to put a new Dayco belt on the drive and tension it correctly. The old belt is probably ruined due to excessive slip and glazing. The initial tension should be set according to the recommendation of Dayco belt engineers. This 6-rib belt should be tensioned to 35 pounds per rib, or 210 pounds. Use a tension gauge designed for multi-rib belts to test the tension. This first reading is 120 pounds. Continue tensioning and gauging until the correct tension is reached. This belt is now tensioned to the recommended tension of 210 pounds. Remember this number. Here's an alert. The next step is usually skipped, which is the cause of most tensioning problems with serpentine belts on locked center drives. Start the engine and run in the belt for 3 to 5 minutes. This will warm the belt slightly and allow it to seat into the pulleys on the drive. After the run-in, recheck the tension. This belt now registers 150 pounds of tension instead of the initial 210 pounds. There are no video tricks here. This is a real reading. If the customer had driven away without a run-in, they would immediately have an under-tensioned belt, destined to squeal and return. After the run-in, the belt should be retensioned to 30 pounds per rib, or 180 pounds. Now the belt is correctly tensioned. With correct tensioning, the belt can now perform as it was designed to, without slipping or belt squeal. The same run-in and retensioning procedure should also be used for V-belt drives. Consult Dayco's Facts and Data Catalog for correct belt tensioning data. The previous procedures were for locked center tensioned accessory drives. If squeal occurs in a drive with an automatic tensioner, replacing the tensioner should restore proper tension and remedy the noise problem. An accessory drive is a highly engineered precision system, of which the serpentine belt is only one element. When belt noise is the problem, the solution may lie with any of the drive's elements. Use the procedures just presented to make sure all the elements are functioning correctly, and don't always blame the belt.